In this video, I'm going to show you how to find the determinant, how to find a cofactor, and how to find a minor. So the first example, we start from finding the determinant by expanding by using the cofactor. So this is a determinant of the matrix A. So let me let this is a matrix A. Now we want to find the determinant. So the determinant is coming from, you can select any row you wanted or any column. And normally we use the row 1. And we use these 3 elements to expand them into the minor form. And from there we can find the determinant. So let me show you the work. So we take the first entries on row 1, which is 2. And then I create the 2 by 2 minor form. So those 2 by 2 minor form is getting from the remaining 4 here. So you have 2, -1, -2, and a 2. Now we move on to the next one. Plus, when you find the determinant by using the cofactor, sign doesn't matter. And the pattern of the sign change, they always has the same pattern. So start from, on the row 1, we start from positive, negative, positive. When they move to the row 2, the sign change to negative, positive, and the negative. When they move to the row 3, it changed to positive, negative, positive. So they are alternative sign changes. So when we go to the row 2, I need to change this sign into the minus. So I put minus, and now I take the second element on the row 1, which is 3. And then, let me erase this 2 line here. Okay. So now I draw the 2 line that intersect at 3. So the remaining 4 will turn to the minor of the element 3. So we have 2, -1, 3, and a 2. Now we have one more to go, plus 1. So the cofactor at this location is 1. Now the remaining 4 would be this 4. So we have 2, 2, 3, and a -2. So 2, 2, 3, -2. Now we continue to solve it. We always start from this direction, do the multiplication. So you have 2 to 4 minus -1 times -2, you get a positive 2. Minus 3 multiply 4 minus times 2, you get a -3. So minus -3 plus 1. Since it's a 1, it doesn't matter. We can ignore the 1. So I start from 2 by 2 times -2, you get a -4 minus 6. Now we simplify. Subtract these 2, you get a 2. So 2 to 4 minus 3 times 7 plus -10. So we have 4 minus 21 minus 10, which is the -27. Now, -27 represent the determinant of these 3 by 3 matrices by using the factor expanding. Keep in mind, this is determinant. With the determinant, it will help us to find the inverse of the matrix. Another example, we need to find cofactor and the minor. We start from finding the minor. This notation tells us they want you to use the element at that location, row 3, column 2, which is 9. So they want you to find the minor of the element 9. So the first step is draw the vertical line and the horizontal line that intersect at row 3, column 2, which is 9. Now the remaining 4 will turn to the minor. So I have 8, 3, 9, negative 5. Continue to solve it. You have negative 40 minus 27. So the minor at row 3, column 2 is negative 67. Finding the cofactor at that location, row 3, column 2, the only differences between these two would be the sign change. When you find the cofactor, you need to consider the sign. And the pattern of the sign change always has the same. Row 1, you will have positive, negative, positive. Row 2, you will have the negative, positive, negative. Let me change the color. Okay. So row 2, we have negative, positive, negative. Row 3, you turn to the positive, negative, positive. So on the row 3, column 2, the sign is a negative sign. Let me put a solution here. So I need a negative sign stay outside of the minor form. Now the minor form would be A3, negative 9, and a negative A3, 9, negative 5. A3, 9, negative 5. It's just like the same here. But the difference is with the cofactor, you need to have the sign stay outside. It could be positive, it could be negative. But this example just give us a negative sign at that location, row 3, column 2. Now I know the result of this 2 by 2 minor form here is negative 67. However, there is a negative sign outside. So the cofactor at that location, row 3, column 2, is a positive value, 67. And the minor at that location is a negative 67.